Well, this is embedded microcontroller lab 4 part 2. Well, what we are trying to do is here. This is the C program code that we create. We are trying to create two integers y and z, and then we try to swap both of the letters by using the function as stated here. So and then we try to convert it to assembly code. So in here, first of all, we use push in order to push R7 into the stack frame, and then in the second line we assign a 20 byte of space into the stack, and then after that in the third line we try to address R7 into the stack frame too, and then in fourth and fifth line is when we store R7 offset 4 and R7 offset 0 into R0 and R1 respectively. So and then next we try to load the address of the first integers load into R3, and then after that we put R3, we store R3 into R7 and offset 12, which is in E. And then next we try to assign the address of R7 as offset 0 into R3, and then the address of R7 and offset 0 into R2, and then also load the address of R7 and offset 4 into R3. These are all stated in 10, 12 and 14, line 10, line 12 and line 14. And then after that, the value of R7 and offset 0, which is initially addressed inside R2, is replaced with the address of R3 and offset 0, as you can see there. So yeah, here, as you can see there. So and then next, then we address the address of R7 and offset 0 into R3, and address the address of R7 and offset 12 into R2. So yeah, as you can see in line 18 and 1A. So after that, the value of R3 and offset 0 is then stored into the address of the second integer, just as stated in the C program code just now. So in this process, the swap process is complete, in which the first integer and the second integer has been swapped, which means the first integer become the second integer and the second integer become the first integer. After that, we add on 20, the value of 20, which is in 1E. We add on the value of 20 into R7, and the stack pointer is created, which is pointed to R7. The value of R7 is then returned and branches to the address contained in link register. R7 is then pushed and link register onto the stack. And then the next thing now, as you can see, and then next in line 2, which is this one, yeah, we create a 8 byte of space which is reserved in the stack frame, and the address of stack pointer is also inserted into R7. A value of 100 is added into R3 as a first integer, and then here a value of 200 is assigned as second integer, which you can see from just now in the C program here. Yeah, this part. And then next, what we are trying to do is the value of 100 is then saved in the address of R7. Yeah, and then offset 4 also, and then the 200 is saved in R7 and offset 0. And then next, the address of R7 and offset 4 is added to R2, and the address for R7 and offset 0 is moved into R3. Then the address of R7 and offset 4 is moved to R0, and the address for R7 and offset 0 is moved to R1. It is all stated in here, and the swap function is called. So that's part of it. And then lastly, the value of R3 is cleared as 0, which is here. It's cleared as 0, and the value is moved to R0. Yeah, move to R0. And R7 is pointed to the top of the push stack, and the address is moved to the stack pointer register. The register is then restored and the stack frame ended. So that's all of it for this part. And then after that, we write another code which is here to improve the outcome and swap function. But in here, we also use the push to push both R7 and LR into the stack frame. So both value inside R2 and R3 are also cleared as 0, as stated here. And then the address of R0 is slotted into R2 and R1 is slotted into R3. After that, the value inside R1 is then stored into R2 and the value of R0 is then stored into R3. So that's the end of it. So this is the end of part 2. Now I will explain the part 3. Yeah. In part 3, first we declare a string function and uses push to push all of the 5 registers into the stack frame, which is here. After that, the value of R1 is cleared as 0. The value is R1 is cleared as 0 and the value of R0 is assigned into R5. And then another string function is created as shown. In the second function, we added the value of 1 to R1 and then in order to count the number of characters in the string. Well, we also create a pointer from R5. We also create a pointer from R5 and point to R2. So after that, as you can see, we create a loop in which 1 will be added, value of 1 will be added into R5 in every loop until the value until the value of R2 slowly decrease until 0. When the value of R2 hits 0, the loop goes back to the previous function. So, and then next, we address a character. Then next, we address character 0, and then assign the address of the character 0 is assigned into R5. Yeah, and then the first character will be used, which in our case we use R31. And then after that, a swap function is created. In this swap function, we write a code in order to assign the address of the last byte into R4 and the address of the first byte into R2. And then lastly, all of the bytes will add up together, and R1 has the value of 5, R3 is cleared as 0 in the beginning of the program initially, as the function is executed as R1 R3, which translates to 5 equals to 5 minus 0 equals to 0. Value of 1 is taken away in R5 slowly until it reaches 0. It reaches 1 or 0 is detected, the program will end here. However, if none of the condition is met, then the program will jump back to the swap function. So this is the assembly code for part 3. That's all.